Welcome back, students. Today, we're delving into a crucial concept in atomic structure called the shielding effect. This phenomenon plays a significant role in understanding valence electrons. Imagine you have an atom, and within it, you have various energy levels or shells. The innermost shells are occupied by core electrons, which are much closer to the nucleus. These core electrons shield the valence electrons, which are in the outermost shell, from feeling the full positive charge of the nucleus. This is due to the repulsive forces between negatively charged electrons. So, the value S comes into play. For valence electrons, S tends to be close to the number of core electrons present. While electrons in the same valence shell don't screen each other significantly, they do contribute slightly to S. This interaction among electrons within the atom has profound implications for the atom's properties. Now, let's dig deeper into this fascinating concept. Welcome back, students. Hello again, young minds. Our journey into atomic structure continues with the concept of effective nuclear charge, denoted as ZEF. Now, ZEF is a critical factor in understanding how valence electrons experience the pull of the nucleus. It's like the net positive charge the valence electrons feel after considering the shielding effect. You see, due to the presence of core electrons, valence electrons are shielded from the full nuclear charge. This reduced effective nuclear charge impacts various properties of elements, like their atomic size and ionization energy. As the number of core electrons increases, valence electrons experience a reduced ZEF, affecting their behavior and interactions. So, you can think of the valence electrons as both adventurers and shielded travelers in the atomic realm. They venture out to interact with other atoms, but their journey is influenced by the protective influence of core electrons. Fascinating, isn't it? Hello again, young. Good day, young scholars. Let's take a moment to appreciate the intricate dance that happens within atoms. Valence electrons, those lively participants in chemical reactions, are surrounded by their core electron companions. Core electrons act as the guardians, protecting the valence electrons from the full force of the nucleus. While valence electrons in the same shell don't shield each other significantly, they do play a minor role in our shielding story. This balance between the core electrons' shielding effect and the valence electrons' desire to explore and interact gives rise to the atomic behaviors we observe. Think of it as a dynamic interplay of forces that shapes the characteristics of elements and their ability to bond and form compounds. Keep this delicate equilibrium in mind as we move forward in our exploration of the atomic world. Good day, young scholars. Welcome back, eager minds. Let's dive even deeper into the concept of atomic shielding. As we journey through different elements, we find that various factors influence the degree of shielding experienced by valence electrons. One of these factors is the energy level or shell in which the valence electrons reside. Electrons in higher energy levels experience less shielding compared to those in lower levels due to their greater distance from the nucleus. This phenomenon has direct consequences for the size of atoms. Elements with more energy levels tend to have larger atomic sizes. This intricate relationship between shielding and atomic properties plays a crucial role in determining how elements interact with each other in chemical reactions. So, remember, the world of atoms is a realm of interwoven factors, and our understanding of them allows us to unlock the secrets of the physical world around us. Welcome back. Hello, curious minds. Now it's time to tackle the shielding puzzle head-on. Imagine an atom as a puzzle, with valence electrons and core electrons fitting together to form a complete picture. Valence electrons, though they venture to interact with other atoms, are never alone. They're surrounded by their core electron companions. These core electrons play a pivotal role in shielding the valence electrons from the full nuclear charge. And what's the key that unlocks this puzzle? It's the concept of effective nuclear charge, that net positive charge that valence electrons truly experience. This understanding allows us to predict properties like atomic size, ionization energy, and chemical reactivity. So, as we put the final pieces of our shielding puzzle together, remember that these concepts are like the secrets of the universe just waiting to be discovered. Hello, curious.